little bit today about my passion for doing research at the interface between chemistry, art, and archaeology. So, when I was in high school, I thought I wanted to be a forensic scientist. Okay, in the 80s, nobody knew what that was, but I thought that idea of being able to solve a crime or investigate a crime using science sounded like a really interesting job. Well, the more I learned about the job, the more I realized it wasn't the job that excited me, it was more that idea of solving a mystery using science. And so I liked archaeology, and then I did a little bit of archaeology, and I realized, there are people who are investigating ancient materials and investigating our ancient past using chemistry. So I figured out that there was this whole area that I could go into for research called archaeological chemistry. Now, this isn't really a subdiscipline of chemistry like organic or inorganic chemistry. This is really taking analytical chemistry techniques, so a lot of the toys that you see on CSI and Bones and TV shows like that, and applying them not to investigating crimes and not to materials from crime scenes, but instead to archaeological materials. And we work very closely with archaeologists and conservation scientists with the idea of trying to apply these techniques to archaeological materials in order to understand human behavior in the past. So all of these questions come down to what can we learn about people? And the materials that we investigate are everything from a tiny single fiber from a textile to an entire foundation of a building, and everything in between. Now, when I was a graduate student, I got involved in studying rock paintings. And rock paintings are unique artifacts. They're found all over the world, everywhere people have been. And because they're outdoors and they're exposed, unlike most archaeological artifacts, they are disappearing in many cases. Now, a lot of times the disappearance is really just due to weathering, like the one on top. But very often, at some of these archaeological sites, there's actually active destruction by other people. And so you can see this image on my left. That image has been knocked over, and that was dynamited off of the wall of the cave by a rancher, for whatever reason. I've also heard stories about rock art panels being removed in whole with a saw or a cutting tool, and then being taken away by collectors. Now, very often, archaeologists find that rock paintings are all that's left of certain cultures. And so this other image is of a rock shelter in southwest Texas, and you can see the big pits dug in the ground. And those pits are where people have gone through and dug up all of the pretty artifacts, but completely destroyed the archaeological context. And so the only thing at this site that remains where the original people put it is the rock art on the walls. So what does chemistry have to do with this? Well, there are a couple of questions that chemistry can address about rock paintings. And the first question we need to ask is, what are the paintings made from? If we can answer the question of what the paintings are made out of, we can first understand something about people's technology. What kind of materials did they choose to use to create these images? And then, once we know what those materials are, that can help us with the second question of how old the paintings are. So if the paintings contain some kind of organic binder, so animal fat or plant juices or something like that, then we can use that to radiocarbon date the paintings. So those are a couple questions that chemistry can help us answer about rock paintings. Now, this illustrates a question that archaeologists can ask that science simply can't answer. And this image, you can just sort of see there's two colors of paint there, red and yellow, and this figure has 2 heads and 4 arms. And the archaeologist at this site thinks that what this is the shaman who created the rock paintings probably exiting his body and crossing over into the spirit world. Well, that's not something that we can test with chemistry. That's not something that we can answer with science. But it's a fascinating question about the people. And so understanding how old the paintings are can help us connect the paintings through time to the people who created them. There we go. So what kind of projects do we do here at EMU? Because of all this work that I've done with rock paintings, I get a lot of interesting emails, some more so than others. One time I got an email from someone who wanted to know if I could radiocarbon date the paint on a wall in his apartment in New York City to prove to his landlord that wall had been there when he moved in. So that's an example of a project we didn't do. Other times I get ones that I just can't let go. And a few years ago, Suzanne Baker, an archaeologist in California who's worked in Nicaragua for many years, contacted me about a site that was completely unknown outside of the local area until just a few years ago. And would I be interested in being part of the expedition to go and learn more about these paintings? Well, how do you say no to something like that? So Cueva La Conga is located in the far northern jungles of Nicaragua, very close to the Honduran border. And this site is obviously a ritual site. People were doing something at this site. And we've got carved rock formations and rock paintings. And probably my favorite rock paintings are the handprints, because you can really truly see the people in the paintings there. Now, because this place is so remote and so hard to get to, doing an archaeological dig there was just not going to happen. So we wanted to know, what could we learn from the smallest amount of time and money from these paintings? And so what we decided to do was try to radiocarbon date them, try and determine how old they are. So to get to this site, we drove until we ran out of road, and then we drove into the jungle in a 4x4, and then, well, I don't know. What did we do? There we go. We rode mules until we crossed over the mountains and got to the small town where we stayed. And then the next morning we had to hike several miles to get to the site. So all of this effort just to get to the rock art site. And then we had one day at the cave to collect samples. Very, very small samples. We tried to be as careful as possible so that we didn't induce any damage to the paintings that was visible. And then we brought those samples of paint back here to the lab at EMU. And so my students and I did some chemical analysis, and we were able to radiocarbon date several of the paintings at the site. And what we found was that Cueva La Conga has been in use by people for the last 1,200 years. The oldest paintings, which were very fragmentary, were about 1,200 years old. The newest ones dated to around the time of European contact, and the other ones that we dated all fell into this range around 700 years ago. And so these are the very first radiocarbon dates ever for rock art in Nicaragua, and they were done here at EMU. So before I came to EMU, I worked with archaeologists at St. Mary's City, and this was the original capital of the Maryland colony. And one day, the archaeologist came into my office and handed me this brick. And he said, "Can we figure out where this came from?" So the question really was, did this brick come from the old world, or was it made locally? Was it made in Maryland? So there are lots of stories on the East Coast about buildings being made out of ballast brick that came in ships. And he really didn't think that was the case here, but he wanted to know if there was any way that we could test that. So the reason that he didn't think that they were ballast bricks was this is a really important building. So this church, this chapel, was very important to the Maryland colonists. Maryland was a Catholic colony, and this was the first Catholic church built out of bricks in all of British North America. Now, you would think for an important building like that, there would be historical records. No historical records of this of the building of this. So what we wanted to do was figure out, where did the bricks come from? So when I came to EMU, we finally were able to carry out this project, and we took samples of the bricks and placed them into the heart of a nuclear reactor at the University of Michigan. And what that does is it activates the nuclei to give off a symphony of gamma rays. And those gamma rays then tell us what elements are present. And so the tones tell us what elements, the intensity tells us how much. And we can put that all together into a chemical fingerprint, and then we can draw a graph that allows us to compare the fingerprints. And what we found was that the clay from the St. Barbara's hillside, another area of the site, matched up pretty much the same with the chapel bricks and many of the other bricks from historic St. Mary's City. Now, the only thing we had were foundation bricks, because all of these buildings were torn down in the 17th century when the capital moved from St. Mary's City to Annapolis. Another site, different clay. So we thought this was pretty interesting. Now, if you go to St. Mary's City, if you're ever in the Washington, D.C. area or looking for a few-hour side trip, you can go and visit the rebuilt chapel. And on the little placards out front, you'll read about how EMU students and faculty worked to solve the mystery of the bricks. Now, we do all kinds of other projects too. We're working on developing techniques for non-destructively radiocarbon dating fragile artifacts. That reed artifact on the bottom is just a few inches long, and so traditional methods would destroy the artifact. We're investigating residues on stone tools and ceramics. This artifact is from Michigan, and we found that for sure it has pine resin on it, but was that pine resin there from the Paleo Indians who built this, or who made this artifact? Okay, so we don't know if this is from the Paleo Indians or not, because this artifact was actually found by a farmer. He gave it to his kids to play with in the early 20th century, and so we don't know what this residue means. So again, the chemistry can't answer all of the questions. There we go. So most of our projects right now are involving projects with the Detroit Institute of Arts. We're trying to identify organic colorants that come from plants and even insects in textiles, paintings, and manuscripts. So I hope I've shown you a little bit that it takes an army of people to do these projects, and these are just some of the students who've been involved, and the many, many collaborators that we work with on all of these projects. So I hope today I've given you just a tiny insight into how chemistry can answer a lot of questions about archaeological materials and investigate the mystery, but it can't answer every question, and that's what keeps it exciting. Thank you.